Data structures. Data structures are specialized formats for organizing, processing, and storing data. They are the foundation for designing any efficient algorithm, or let us say for an efficient software. So, as a computer science student, as an algorithm student, knowledge on data structures is a necessity for you. Why is this a necessity? The reason is whenever you want to design an efficient algorithm, the first step is to identify the right data structure in which you can store your data. If you don't get this step right, accessing any element from your data will be inefficient. Doing any operation on your data will also be inefficient. What will be the end result? The end result will be that it will look like your algorithm design is wrong. The reality is your choice of data structure is wrong, because of which it is impossible to design the right algorithm. In order to understand this, let us take a simple example. In your day to day life, where do you keep your belongings? Do you randomly keep your belongings here and there? No, you will keep every single item in specific places such that they are easy to access. For example, if you have a mobile phone, where will you keep your mobile phone? Will you keep it inside a bin inside your kitchen? No, because you know it is inefficient. Instead, if you keep it on top of a table, whenever you want to access this mobile phone, it will be easier for you to access. Or let us say you are going out. If you are going out, will you keep your mobile phone in your backpack? No, because you know if you keep it inside your backpack, whenever you want to access your mobile phone, you will have to open the backpack and then take the mobile phone out. Instead, if you keep it in your pocket, it will be much easier for you to access whenever you want. The same way, if you observe carefully, you will understand that for every single item that you use regularly in your day to day life, you will automatically be keeping them in the right places such that they are easily accessible for you. If you have a car or a bike in your home, will you keep this car inside your home? No, you will keep it outside, let us say in a car porch, such that whenever you want to take this car and go out, it is easier for you to come here, take it and go out. The same way, for every single item that you use in your life, you will understand that you are automatically keeping them in the right places. The same way, whenever you want to design an algorithm, you should keep your data in the right storage space, that is, in the right data structure, so that you are easily able to access this data. So this is true for any item. You can check any item that you regularly use. Let us say your wallet, you will safely keep it in a safe. Or if you have a lot of books, you will be keeping them in a bookshelf from where you can easily access. Or let us say you have dress, you will be keeping it in a cupboard from where you can easily select and access the right one. I want to show you one more example in order to make you understand that how a wrong choice of data structure is going to take your algorithm for a toss. That is, once you make this wrong choice, you'll never be able to design the right algorithm. In order to understand this, we'll take another example. You are going to a market. When you're coming back from the market, let us say you bought ice cream. So on one hand, you have ice cream, and on the other hand, you have a mobile phone. This is how you are coming back to the home. So what do you want to do now? You want to keep your mobile phone and the ice cream in the right places. Let us say you will keep your mobile phone on top of a table and ice cream inside your refrigerator. Let us say there is a freezer in which you are keeping your ice cream. If this is the case, let us see how to write an algorithm in order to access your mobile phone whenever it rings. So algorithm means step-by-step instructions. Whenever your mobile phone rings, what should be the algorithm that you should write in order to access your mobile phone. Let us say it will look something like this. If your mobile phone rings, what should you do? You should go to the table and then pick your mobile phone. This is the basic algorithm, simple algorithm that you can write in order to pick up your mobile phone whenever it rings. So this is a very simple algorithm you can see in order to pick your mobile phone. Now imagine that instead of this scenario, if you interchange the data structures, that is the storage space, if you kept your mobile phone inside the freezer and ice cream on top of the table. If this is the scenario, then your ice cream is here on top of the table and your mobile phone is inside the fridge. If this is the case, how will this algorithm change if you want to write the same algorithm to pick up the mobile phone whenever it is ringing? This time you may have to write like this. If your mobile phone rings, what should you do? Let us say table is where you are generally sitting. So previously you simply have to go to that table which was near to you. This time you have to go all the way to the place where your refrigerator is kept. So the first step is you have to go to the refrigerator, which is a much costly operation than going to the table, because table is near to you while refrigerator is somewhere far. Secondly, once you reach here, you have to open the door. Let us say you have to open the door of the refrigerator. You have to pick your mobile phone from the refrigerator, and then once you attend the call, you have to keep the mobile phone back into the refrigerator again by opening the door. So if you see this, the algorithm got much complex when compared to your previous algorithm. See, I know this is totally illogical to keep a mobile phone inside the freezer, but I want you to understand that it is the same scenario if you choose a wrong data structure in order to store your data while you're designing an algorithm. This scenario is something you can easily relate, because of which you will be feeling very weird. But in case of algorithms, it is the same situation. The only difference is you are not so accustomed to that scenario that you are not feeling how difficult it is to write an algorithm once you put data in the wrong data structure. So every time you are designing an algorithm, I want you to imagine this scenario. Imagine this scenario and keep in mind that you have to make the right choice of data structure first and then design the right algorithm. Okay. So now that you have an idea of why you want the right data structure, let us see what are the advantages that you will get once you design the right data structure. Once your data structure design is right, what are the advantages? First advantage is it will reduce your time complexity. What is time complexity? It tells you how fast an algorithm can run. Whenever you make the right choice of data structure, your algorithm will be faster, which means your time complexity will be lower. Similarly, you will also decrease your space complexity. What is space complexity? Space complexity is the additional space you are using in order to run your algorithm. If your data structure is the right one, the right choice, you will be able to make sure that you will run the algorithm by using minimal possible space. What are the other advantages? Another one is better understanding of the code. If your data structure is simple, the code will be simple and not complex. So you will have a simple code, because of which you will have better understanding. It will be more readable. And whenever you want to modify this code, it will be easier. So these are the advantages you will get whenever you choose the right data structure. Then the question is, what are the different standard data structures that are available? Data structures can be generally divided into two classes. One is linear and the other class is non-linear. Inside linear data structures, you have data structures like arrays, linked list, stacks, queues, etc. These are all linear data structures. On non-linear side, you have trees, graphs, heaps, hash maps, etc. There are a lot of data structures. These are few of them which will tell you these are the linear data structures and these are non-linear data structures. Let us just have a basic overview of how different data structures are used for different purposes. So first of all, let us understand arrays. When do you generally use arrays? Arrays are simple data structures which can store element in contiguous memory locations. Generally, you use arrays whenever you want fast access, or let us say indexed access. What is indexed access? That means if you want to directly access the element at, let us say, third index, you can directly go to the third index and access this element. This is called index access. So whenever you want fast access like this, you will be using array data structure. Next one is linked list. When will you use a linked list? Whenever you want to dynamically modify the size. This is when linked list is generally preferred. Let us say you want to insert a new node into this linked list, or you want to delete an element from this linked list. It is easier with a linked list because you can dynamically modify this data structure. Then you have stacks. Stacks, it works the same way. You stack a set of plates. That is, you will have one, next one above it, next one above it, and so on. This is generally used in backtracking algorithms, or let us say in expression evaluations. Why is it used in these sort of scenarios? Let us say you want to do some backtracking. If you want to see the previous step, what will you do? You will just take out the last element from the stack. If you want to see one more step back, you can take one more element out of the stack. So this way, it is easy to implement any backtracking algorithm. What about queues? Queues are used whenever you want to do order processing, or let us say for task scheduling. Why are queues used for these purposes? Let us say you want to do some order processing. You got first order, then the second order, then the third order, and so on. How do you want to process these? You have to process these orders in the same order in which these were received. That is, whichever was the first order, you want to process it first. Then whichever was the second order, you want to process it next, and so on. So in these case of scenarios where you want to maintain the order, you will be using queue data structure. What about trees? Trees are data structures which are used for representing hierarchical data. That is, if there is a parent and this parent has two children, these children, they are having further children. These sort of hierarchical data, whenever you want to represent hierarchical data, trees are always the preferred data structures. What about graphs? Graphs are used for network routing algorithms, or maybe for social networks. In social network, if you want to represent relationship among different people, it is easier to represent using a data structure like graph. Let us say you have a person A, another person B, another person C, and one more person D. You want to see who are friends with whom. If you represent this with a graph, you can easily represent this because let us say A and B are friends. So you will have a link between A and B, an edge. Then if B and C are friends, you will have an edge between B and C. If C and D are friends, you will have an edge between C and D. Let us say A and C are not friends, then you will not have an edge here. Or if B and D are friends, you will have an edge here as well. So looking at this graph, it is easy to say who all are friends with C. You can simply see which are the outgoing edges from C. You know B and D are friends with C. So to represent any of these sort of social networking data, it is easier to do with graph. Then you have hash maps. What are hash maps used for? Hash maps are used for hash maps or hash table. They are used for key value pairs. What are key value pairs? If you want to store different values, what you do is you will have different keys corresponding to those values. Then you will insert these key value pairs in your hash table, and whenever you want to access the value, you can directly search for the key and get this key in quick time. Once you identify the key, you can easily get the value corresponding to key, and this operation of searching for the value will be much faster. So in such scenarios where you want to search and find out your value in order of one time, this is where you generally use hash maps or hash trees. There are many more data structures. We'll see those data structures as we go on with the course. So this is it about data structures. The most important thing is that you should identify, you should understand how important are data structures for designing algorithms. Understanding the strengths and limitations of various data structures, this will allow you as a programmer to select the most suitable data structure for the situation, and this will make your algorithm much more efficient. So this is why you should have good knowledge on data structures.